All right, hello. Welcome to problem 4 from the homework. Let's just jump right into it. The lid of a roof scaffold weighs 85 pounds. It is hinged at corners A and B and maintained in the desired position by a rod CD pivoted at C. A pin at the end of D of the rod fits into one of the several holes drilled into the edge of the lid. Assume that the hinge at B does not exert any axial thrust. So remember from the last problem, axial thrust means along this axis right here. So there'll be no B of X force. So let's go right in and draw our free body diagram. We'll start off at BY and BZ. At A, we have it in all directions, so this way, that way, and that way. AX, AZ, AY. At the center of the plate, we have the weight. We have the weight going down, and then notice this rod right here acts a lot like the tension that we've been dealing in class. So instead of drawing our pin forces like dx, dy, and dz, we're just going to draw one force going along the rod, pointing from C to D, and that's FCD. So that's our free body diagram. Let's go ahead and solve for the magnitude of the force exerted by rod CD. So we're trying to find this FCD right here. I already drew out this triangle in case you need a refresher. This is the law of sines, where this A length over sine alpha is equal to B over sine beta. I rotated this triangle to have our 7 length on the bottom and our 15 length going along the hypotenuse like that. And so using the law of sines, we can have sine of theta over 7 is equal to sine 50 degrees, which we're given, over 15. And we'll get that theta is equal to 20, around to 21 degrees. Then we want to find this angle from the bottom to here. Sorry, from here to here. And we can do that by adding our 50 degrees plus this 21 degrees. So we'll call that, ignoring these variables right here that we haven't used in our problem, or we'll call it omega, and we'll say our W omega is equal to 21 degrees plus 50 degrees, which is equal to 71. Now that we have that angle, we can break up FCD into its components. So FCD is going to be equal to the magnitude sine of omega, and that's going to be in the J component, plus FCD cosine of omega in the K component. So we have our FCD. Now we want to take the moment about either A or B to get rid of those unknown values. In this case, I'll take the moment about B and set it equal to 0. And writing out our equation, we have that this length 26 points from B to A. We also have our force G, which you can find by breaking up. We know that G is going to be half of this right here, so 13 inches this way. This is the hypotenuse, so you can break that up into a triangle like this. It's 32 inches long. This is our 50 degrees. You basically can do 32 cosine of 50 and 32 sine of 50, and then you divide these values by 2 to get its halfway point. Once you do that, you can use a cross product to get to from B to the point G to find the weight, and then um, take the direction vector from B to the force CD right there. That will, and then you set those equal to 0, and you'll get in the I component that the weight times 16 inches cosine of 50 degrees minus 0.94521 FCD times 7 inches is equal to 0. We only have one unknown here, which is FCD. Solving for that gives us 132.1 pounds. And that is the final answer. Now the reaction at A and B. To find those, we do what we did. We take the moment about B, like we did in the last part. And this time, we already found FCD, but our not our our J component of the equation will have 0.32646 FCD times 26 inches um, minus, not minus W, minus A of Z 26 inches set equal to 0. We found FCD in the last part, which means we can solve for A of Z, which is equal to negative 43.1 pounds. We can do the same thing in the K component, where we'll have an equation that we can solve for A of Y, which will give us negative 82.4 pounds. And as we can see from this I component equation, there's no contribution from A. So we know that A of X is equal to 0 pounds. After doing that, we can set up our Fx equals 0, Fy equals 0, Fz equals 0 to solve for By and Bz. And we'll get that By is equal to 42.5 pounds. And we'll see that Bz is equal to 0 pounds. And that gives us the answer for this problem.